On this accord, P16F3 points to a low voltage problem on the ECM/PCM starter cut relay 1 control circuit. In plain terms, the PCM is not seeing that starter cut control circuit behave the way it should. The car may still start, it may have an intermittent fault, or it may come in as a no start. The broad fault areas can include the starter cut control wire, relay circuit board connections, the ignition feed side, the under-dash fuse and fuse box area, or PCM software and PCM control. Before testing, save the captured data and onboard snapshot. Then start with the basic system checks so you know whether this is a hard fault or something intermittent. First, try to start the engine. If the engine starts, treat this as a code verification path and go straight into duplicating P16F3. If the engine does not start, skip ahead to checking the starter system input with the scan tool. With an engine that starts, turn the vehicle OFF, then turn it back on. Clear the code with the HDS, then check for pending or confirmed codes. If P16F3 comes right back, the failure is duplicated and you can test the SDCUT-RLY1CL circuit for a short to ground. If P16F3 does not return, call it intermittent for now. The system is okay at this moment, so concentrate on poor connections or loose terminals at the relay circuit board and the PCM. For a duplicated code on a vehicle that starts, turn the vehicle OFF, jump the SCS line with the HDS, then disconnect relay circuit board connector A, the 8P connector and PCM connector A, the 51P connector. Check continuity on the SDCUT-RLY1CL line between PCM connector A, terminal no, 33 green wire and body ground. If there is continuity, repair the short in the SDCUT-RLY1CL wire between PCM-A33 and the relay circuit board, then verify the repair. If there is no continuity, that wire is okay. At that point, update the PCM if it does not have the latest software or substitute a known good PCM, then verify the repair. If the engine did not start at the first check, turn the vehicle on. On an automatic, put the shifter in P or N. On a manual, put it in neutral and press the clutch pedal. Watch the starter cut control return parameter with the HDS. The expected threshold is on. If the current condition matches that threshold, keep going in this P16F3 circuit path. If it does not match, leave this path and diagnose the engine will not start symptom. Next, turn the vehicle OFF, jump the SCS line with the HDS, disconnect PCM connector A, then turn the vehicle back on. Again, use P or N on an automatic or neutral with the clutch pressed on a manual. Measure voltage on the SDCUT-RLY1CL circuit between PCM connector A, terminal no, 33 green wire and body ground. If battery voltage is present, update the PCM if needed, or substitute a known good PCM, then verify the repair. If battery voltage is not present, move down the circuit and test from the relay circuit board side. With PCM connector still disconnected and the vehicle on, measure voltage on the SDCUT-RLY1CL circuit at relay circuit board connector A, terminal no, 5 green wire to body ground. If battery voltage is present there, the IG1 ACG feed is okay, and the problem is an open in the SDCUT-RLY1CL wire between PCM-A33 and the relay circuit board. Repair that open, then verify the repair. If battery voltage is not present, keep moving upstream to the IG1 ACG side. Now measure the IG1 ACG circuit at relay circuit board connector A, terminal no, 4 pink wire to body ground, with the vehicle on and PCM connector disconnected. If battery voltage is present, replace the relay circuit board, then verify the repair. If battery voltage is not present, check the fuse feeding this part of the circuit. Turn the vehicle OFF and check the no, B13-15A fuse in the under-dash fuse/relay box. If the fuse is okay, continue with the IG1 ACG open circuit check. If the fuse is not okay, replace the no, B1315A fuse, turn the vehicle on, then back OFF. If the fuse blows again, repair the fault to body ground on the no. B1315A fuse circuit, then verify the repair. For the IG1 ACG open check, disconnect relay circuit board connector and the under-fuse/relay box F connector. The F connector is the 18P connector for the applicable USA, Mexico, or Canada layout. Jumper terminal no. 11 pink wire at that under-fuse/relay box connector to body ground. Then check continuity from relay circuit board connector A, terminal no. 4 pink wire to body ground. If there is continuity, the IG1 ACG wire is okay. So replace the under-fuse/relay box for the applicable market, then verify the repair. If there is no continuity, repair the open in the IG1 ACG wire between the under-fuse/relay box and the relay circuit board, then verify the repair. Keep verification separate from the circuit tests. Turn the vehicle OFF, reconnect every connector, exit SCS mode with the HDS, then turn the vehicle on. Reset the PCM with the HDS, do the PCM idle learn procedure, and check pending and confirmed codes again. If P16F3 is still indicated, recheck for poor connections or loose terminals at the relay circuit board and PCM. If the PCM was updated, substitute a known good PCM and recheck. If a PCM was already substituted, go back to the beginning of the diagnostic path. If P16F3 is not indicated, the result depends on what was done. If the PCM was updated, the troubleshooting is complete. If a known good PCM fixed it, replace the original PCM. If other codes are present, check what they mean first. The clean way through P16F3 is to prove whether the starter cut control circuit is shorted, open, missing its feed, or being driven incorrectly before condemning a module. Follow the voltage and continuity results in order, then verify the repair and make sure the code stays gone. For more diagnostic training, visit stepdiagnostics.com.